Hey there folks, we are in pre-algebra 9.2 today, and we're talking about simplifying square roots. Okay, so first thing I want to talk about is comparing the products here. What does product mean? Well, multiplication, and here's our multiplication there, and there's our multiplication there, and these are two separate problems. So the square root of 4 times the square root of 16. Well, if you were to evaluate that expression, you would say, well, what's the square root of 4? That's 2. Bring down our multiplication symbol. What's the square root of 16? It's 4. So 2 times 4 is 8, right? But let's think about this, okay? Here we have a little bit different of a thing. And this says, what's the square root of 4 times 16? Well, remember, radical symbol is like a grouping symbol, so I need to do what's inside first, just like a parentheses. And 4 times 16, well, that's like 32 times 2, that's 64, right? So this now asks, what positive number times itself gets you to 64? Well, let's think about that. Well, 8 times 8 is 64, right? So I would rewrite that as my final answer as 8. But look, same answer, right? So that brings us to what is called the product property of square roots. And what does that product property of square roots actually say? Well, algebraically, that should be not root a, it should be roots. Algebraically, it says that if you had some number a times some number b, that is the same as saying the square root of some number a times some number b. That's the same as saying the square root of a times the square root of b. Separately, okay? We just proved that up here with that little example. And we'll call this thing here item number 2. So item number 3 is a problem I want you to try. I would like you to try out the square root of 4 times 9. Okay? And then next to it, I want you to do this. Square root of 4 times the square root of 9, just to prove that you understand. Alright, so hopefully you realize, 4 times 9, that's 36. What positive number? Because this is a positive square root. We didn't have a sign. I could write in the positive if I want. What positive number times itself gets me 36? Don't need that. That would be just plain old 6, right? Here, I'd say, what's the square root of 4? It's 2. Positive square root of 4, I should say. What's the positive square root of 9? That's a multiplication symbol there. It's not a negative. Well, 3 times 3 is 9. What is 2 times 3? That's 6. Same answer both ways, right? Of course. But what if we had something like this? Well, 3 times 64. 3 times 64, let's see. Well, 3 times 64, that gets you 192. Now 192 is not a perfect square, so it's actually not helping me get any closer to the answer. So let's use the product property of square roots to break this down. Remember that I can rewrite this as the square root of 3 times the square root of 64 individually. Okay. Now what is the square root of 3? Well, there is no number exactly that is the square root of 3. There's no number times itself that equals 3. 3 is not a perfect square, so I'm going to leave that as root 3. Times, well, what's the square root of 64? Well, actually, 8 times 8 is 64, right? We're talking about the positive root here. So I get root 3 times 8. And actually, that's about as simple as I can get. The one other thing I would do is I'm going to put terms without a radical first. So using the commutative property of multiplication, I'm going to have these things switch spots. So it's going to be 8 times the square root of 3. And I'll simplify it even further. I don't need that multiplication symbol there. So I'm just going to do 8 root 3. And we know that means 8 times the square root of 3. That's just a little simpler. And there you go. We would be done. What if you were given this, though? And they say, evaluate that. And they say, evaluate and leave your answer in square root form. Okay. Well, let's see. 200. Is it a perfect square? Let's see. 10 times 10 is 100. So 20 times 20 must be 200, right? Wrong. 20 times 20 is 400. So that's not going to work. And actually, you could keep trying and trying and trying and trying, but 200 is not a perfect square. So how do I evaluate this but leave it in square root form? Because if I just take the square root of 200 in my calculator, it's going to give me 14.14213562. But that's a decimal. I don't want a decimal. I want to leave my answer in square root form. Again, the product property of square roots is going to come in hand here. So what I'm going to do is change square root of 200 into the square root of two numbers that multiply to get 200. Okay? And I'm going to pick 100 times 2. Is that the only way you can do it? No, but let me show you why I did that. 200 is not a perfect square, but 100 is. And remember, now that I have this set up like this, I can break it up even further by saying the square root of 100 times the square root of 2. And since I know that 100 is a perfect square, the positive square root of 100 is 10 times 2 is not a perfect square. There's no number times itself that equals 2, so I'm just going to have to leave it root 2. And to finalize my answer, I'm just going to simplify it by getting rid of that multiplication symbol. I don't need it. It's redundant. Turning it from 10 times root 2 into 10 root 2. And I'm done. So why don't you try this one? Evaluate that and leave in square root form. All right, so there's a couple ways you can do this. So let's try one of them. Well, 180, is it a perfect square? It's not. Too bad for us, but that's okay. Can I change it into some number times another number, and one of those is going to be a perfect square? Well, what'd you come up with? There's a couple ways you could do it, but I came up with 20 times 9. Right? 20 times 9 is 180. Okay, so now that I have it in this form, I realize that, hey, 9 is a perfect square. So I'm going to break this thing up into the square root of 20 times the square root of 9. I can do that because the product property of square roots. What's the square root of 20? It isn't a perfect square, so I'm just going to leave it root 20 for now. Times, what's the positive square root of 9? It's 3, right? So let's see. Now we know that we want to put the numbers without the radicals first, so move him there, move him there. Now I have 3 root 20, right? Yeah, but am I done? I'm not, and here's why. Because 20 isn't a perfect square, we know that, but there is a perfect square that multiplies by something else to get 20. So let me show you what I mean. 3 root 20, we said, means 3 times square root of 20, right? But 20, square root of 20, could be broken up into the square root of 4 times 5, right? 4 times 5 is 20, so we can do that. But what is the square root of 4? Well, I know 4 is a perfect square, so I'm going to change this into 3 times square root of 4 times the square root of 5. And that helps you now because I have 3 times the square root of 4. What positive number times itself gets you 4? 2 times square root of 5. Now we got to simplify this further. I can take 3 times 2 because they're both outside the radical symbol, so it's just like saying, well, it's 3 times 2, and we know that's 6 times root 5. Okay, so the question is 5 a perfect square? No, there's no number times itself that gets you 5. Okay? But can you take 5 times, or can you take some number times something else to get you 5? And one of those is a perfect square? Well, and by that I mean, is there something times something else that equals 5? No, right? No integers or positive or negative non-decimal numbers. The only thing I could put in there is 1 times 5. But one's a perfect square because 1 times 1 is 1, but we don't really count that here. 5 is not, so I'm actually done, except for I could rewrite this as 6 root 5. Okay, I know that's a little complicated and it can be a little tedious, but I promise you with practice you will totally get it, so keep at it. All right, so let's talk about the quotient property of square roots. So what does quotient mean? Well, it means we're going to have some division, property of square roots, so something with division and square roots, right? So if I gave you that, what would you do if I said evaluate or simplify that? Well, you would probably say, hey, you know, square root symbol is kind of like a grouping symbol, so I need to do what's inside first. And inside, there's 100 over 4, otherwise known as 100 divided by 4, which is the same as 25, right? And we'd say, oh, what's the positive square root of 25? Well, it's 5, and I'd be done, right? And you would be totally correct. But let me show you something that we can do. Square root of 100 over 4. The quotient property of square roots says that if I have some whole number or fraction inside a square root, I can break this one specifically up into the square root of 100, so the numerator by itself, over the square root of the denominator by itself. Okay. Now, is that super beneficial and helpful in this specific problem? No, but I'll show you why in a minute. It'll help us with other more complicated ones. So anyway, what's this positive square root of 100? Well, it's 10. What's the positive square root of 4? It's 2. So now I just have to simplify 10 over 2, which is 5, and look. Same thing, right? Okay, cool. So check this out. If you had, man, I'm not numbering these well, am I? Keep forgetting. That was 6 up there, so this is item number 7 with the quotient thing. Item number 8 will be a problem for you to try. I want you to simplify. Simplify or evaluate square root of 16/25. Take a minute, try that, see what you get. All right, so what I get when I do that is I could say, well, can I divide 16 by 25? Actually, I can't, right? I mean, I could. I could say, well, see, 16 divided by 25 is 0.64, but I really don't want to have the square root of 0.64 because it's actually not simplifying. Remember, simplifying means I don't really want decimals if I can have it. I kind of want clean numbers and fractions if I really have to. So let's go about this a different way. Using the quotient property of square roots, I can break this up into the square root of 16 over the square root of 25, right? Well, what's the positive square root of 16? It's 4. What's the positive square root of 25? It's 5. And all of a sudden, I have my final answer, 4/5, right? Pretty cool. Okay, so let's talk about when we have radical expressions and, well, it's algebra, so you guessed it, and variables. Okay? So if I said square root of 4 squared, you would probably tell me, well, 4 squared is 16, and let's see, square root of 16 is 4. So it's interesting that your answer was also the number that was inside the radical sign. Okay, it was the radicand. And if you remember, if I have a squared inside a radical, I could actually cancel them. So instead of doing that whole thing right there, what I could just say is, oh, squared inside a square root, guess what? Just leaves me with the 4, which is the same thing I got up there. All right. So what do you think you would do if you were given that? Well, hopefully you'd realize, hey, a squared inside a square root or a radical cancels, leaving me with the 6 there. Cool. But what about this, though? Well, we've kind of encountered that before, haven't we? If I was to simplify that expression, I'd say, hey, squared inside a square root, goodbye, I'm just left with the x. Okay, you would be totally correct, right? But what about that? Well, what does that say? Well, it means the square root of, positive square root of, 4 times x squared. So we could rewrite that as 4 times x squared. We haven't changed anything yet. We're just kind of restating what's there. But what does the product property of square roots say? Well, it says if I have a bunch of stuff multiplied together inside a square root, I can break it up into something like that. So I'm going to break it up into the square root of 4 times the square root of x squared. Now, what is the positive square root of 4? 2, right? 2 times 2 is 4. Times What is the positive square root of x squared? Well, remember, a squared inside a square root cancels, leaving you with just the radicand. In this case, it's an x. So what is 2 times x? Well, we just simplify that and say it's 2x, and guess what? We are done. So what is the positive square root of 4x squared? It is 2x. All right, so let's try another one then. How about this? How about 32 over 121x squared, or the square root of the whole thing? All right, so what do we do there? Well, remember, we can break it up. Okay, quotient property of square root says I can turn this into the square root of 32 over the square root of 121x squared, right? Okay, so question, what do I do first? Well, we have a fraction bar. Fraction bar is a grouping symbol, so let's work on the top first. 32, is it a perfect square? No, but is there some number I can multiply by a different number that equals 32, one of those being a perfect square? Yeah, actually, I know that, well, I got a fraction here. I can break 32 up into 16 times 2. And on the bottom, I'm just going to rewrite everything for right now. I'm not going to work on that yet. Just working on the top. So what is square root of 16 times 2? Well, remember, the product property of square root says I can turn that into the square root of 16 times the square root of 2 over, and I'm not even going to write the denominator in there yet. We're not getting there yet. So what is the square root of 16? Well, that's actually 4, right there. It became 4. Times, what's the square root of 2? I don't know, so I'm just going to leave it times root 2. All right? So now, let's see. I'm going to rewrite what's in our denominator. Square root of 121x squared. Let's work on him now. 121x squared. Well, again, I can break that up because the product property of square roots. I'm just going to rewrite the top, and I don't need times root 2. I can just write 4 root 2. All right? So again, back to the denominator. I can rewrite that as 121 times the square root of 121 times the square root of x squared. But let's remember, if I have well, actually, let's work on this one first. What's the square root of 121? Well, actually, 11. Right? 11 times 11 is 121. And now we have this times square root of x squared. Well, remember, a squared inside a square root cancel each other, so I'm just left with plain x. And on top, again, I have 4 root 2. All right, so simplifying even a little more. On top, we have 4 root 2. On bottom, 11 times x is really just 11x. Now, can I simplify this anymore? Well, 4/11ths, is that a fraction I can simplify? No. So I am actually done. All right, everyone, that's all I have for you. I look forward to seeing you in class.